That is why Montana is like the worst state in the entire United States and possibly the worst region in the entire world. Cool. All right. On B. Thoughts? What do I do? Help. Liam. Find the distance to the midpoint. What do you mean?
Find the distance from your x1 to x2.
But I don't have x2.
Or I mean to your midpoint.
Okay, so you're walking the same way here, right? We're going to take pure algebra here for a second. Every diagonal line has two components. Akis, give me one of them. Exactly. Don't make me make a seating chart. Give me what every diagonal line has components. Two different components. Name one of them. What moves left and right? Is that which axis? X. So check it out. We have a formula for this as well, right? And it's, does everybody have this? Yeah. Okay, so check this out. If we work in each component separately, we can do this problem without ever drawing it. We can make sense of the math, and I think it's fairly straightforward. I'm going to check your algebra skills, though. Do you want to work? Let's work x direction first. X axis. And I'm just going to say x, just because we're working like horizontally. Cool. Do you know the x coordinate of the midpoint? It's a 3. Everybody okay with that?
Yes.
Now, I know that whatever the x coordinate is on the midpoint, it's just the other endpoints added and divided by 2, right? Do you know one of the x coordinates of one of the endpoints?
Yes, -2.
It's -2. Do we know the other endpoint? No. Does it have an x?
Yes.
It will when we find it, right? What should I call it?
X.
X is a natural choice. Divided by, how does a midpoint work? 2. All right, we're going to algebra this together, right? Meow. And then I'm going to have you guys do the other side. Everybody here took algebra 1. Loved it or hated it?
Mid feelings.
Fair. Like, you're not going to hurt my feelings. Who loves fractions? I actually kind of do like fractions. Even if you do, and we'll just play along. Who loves fractions? Yeah, all right. But check it out. Even if you really love them, what's better than a fraction? Oh my goodness, you're about all filled my class.
Improper.
No fractions would be nicer, right? Everybody agree with that? Okay. Relly, on the right side of this equation, I am dividing by something. What am I dividing by? 2. All right. Who am I going to get here? Michelle, how do you undo a divide by 2?
Multiply by 2.
Where should I multiply by 2? Both sides. Now, my guess is that this is probably what this has looked like for you. Parentheses, a 2, and parentheses, a 2. Everybody agree that that's what you've seen in math? I'm multiplying both sides by 2, right? Now, just so you can see it, I'll put this back. Sometimes I'm lazy. Everything gets multiplied by 2 in the end. Sometimes I just do this. So I don't have to do it on both sides. I'll just say, look, it's going to happen to everything. Are they really doing anything different?
No.
No. Let's do the left side. What's 2 times 3 give me?
6.
Okay, we got it. Big question here. When I distribute this 2 into the other side, that whole top piece would have to be multiplied, right?
Yeah.
But that whole top piece is being divided as well. That was a very obnoxious phone. That wasn't me, though.
Nothing happens.
I don't know. Something happens.
The
If I write my 2 here, do you agree I'm multiplying and dividing by 2?
Yeah.
And what's 2 divided by 2?
1.
Not 0.
1.
It's 1. They undo each other, right? They divide out. Which means on this other side, all I'm left with is -2 plus x. I don't deal with the division because we just undo it right off the bat. From this point, I need a little help solving.
+2 on both sides.
Everybody cool with that? I think I get x equals 8.
Yep.
Now, I did 2 steps because I would really get 8 equals x. What property allows me to do this last step?
The symmetric key.
It is a symmetric property. Yes. Okay. I want you guys. We already found x is 8. I think that's correct. I'm pretty sure it's right. I want you guys to set this up the same way, but instead of working in the x direction, you're going to work in the y direction. You guys set this up. I'm going to give you about 60 seconds, and I'll come talk with anybody individually as needed. All right, coming back together. Let's check it out. For this, when Gian's back. Okay, then yes. All right, check it out. As long as we know one endpoint and the midpoint, we're golden. What is a y value at the midpoint? 4. Do you know either of the y values at endpoint?
Yes.
Only one.
-4 plus y.
-4 plus some other endpoint. I don't know it. It's y is what we'll call it. And all that gets divided by 2? Is the algebra any different than what we just did? No. I'm going to multiply both sides by 2. We get 8 equals what?
-4 plus y.
And what if I want to solve it for y? Draw balance. I won't, but you can say it.
Plus 4.
Add to both sides of the equal sign.
And then you get y value is equal to 8 or to 12.
Awesome. Now, we just took a very, very mathy algebra approach to this problem, right? Didn't even look at the picture. If you are more comfortable looking at the picture, could we?
Yeah.
In fact, I already have it up there. I'll sketch it here real quick. -2, 4, and 3, 4, right? You do not have to sketch it. I just want to show you we can logic this out. -2, 4, is that right? -2, I already lost it. -2, -4. Would you believe it?
Yeah.
-2, -4, and the midpoint was at 3, 4?
Yeah.
Okay, so here's my segment, right? That's up to the middle. And then I'm trying to find, when I extend it out, where's this point, right? Okay, I can't do this just by eyeballing it, but check it out. Diagonals is hard to think about, but each part isn't. To get from here to the midpoint, how many steps did I have to take?
8.
Try again. From -2 to 3.
5.
5.
So I took 5 to get halfway across, yeah?
Yeah.
Let's go 5 more.
10.
Try again.
What?
8. -2 to 3, I go 5 in the horizontal. Let's go 5 more since that was only half of it. And you guys just told me it was where? 8. Okay. Deal. Let's do it in the y direction. To get from here, how many steps up till I get to the midpoint? 8, right? So how many more steps should I take on the second half?
8.
8 more gets me to, hey, look at that. We can do it 100% graphically by making sense of it here. But we just did the exact same thing with the algebra without having to draw the picture. My hope is that when you see 2 options of solving the same problem, that both of these realistically resonate with you. I don't care which one you use, and I hope it's not stressful if I say, hey, look, here's a couple ways to do it. Now you get a pick. If you would like me to not give you multiple ways to do problems, I'm cool to not. Thoughts? Some people don't like multiple ways because then they say I don't know where to start because we have all these different techniques. Okay. Okay. Which way do you prefer, the picture or the math?
The math.
Interesting. Me too. Okay. Cool. So we are getting close to being done here. You guys will be able to tell me one thing, I think. Have you ever seen a theorem?
Yes.
So everybody's heard it, and you might even be thinking of a P word. Finish this statement for me. A squared plus B squared equals?
C squared.
What does that mean? So I'm going to challenge you guys. We're not going to write it out wordy. Our focus is not on the Pythagorean theorem. But I want you to tell me, be able to, I'll give you 60 seconds. Explain to me what it means when I say a squared plus b squared equals c squared. A right triangle is not quite a good enough answer. You're on the right track. Cool. 60 seconds. What does the Pythagorean theorem actually mean? How would you word it and explain it? Let's knock it out, though. We talked about midpoints. We got it. We are going to derive for ourselves what is known as the distance formula. Do you guys remember seeing the distance formula? Did you love it? Okay, fair. Most people don't. The formula is ugly. But if you can remember a squared plus b squared equals c squared, you will always have a way to get this. Rather than me just saying, here's the formula, let's use it, I think it's more valuable if you guys know how to get the formula. And we're going to work in really general terms here today. So, here we go. Given, we're going to sketch a picture for it here in a second, A at the point, I don't know, x1 comma y1, any ordered pair. Don't care where it is. You give me point A and point B, which let's use our powers of deduction. How should I write this other point that's anywhere? Good. X sub 2 and y sub 2. The distance between them, I'm going to say the distance AB is given by, and then I'm going to do some scratch work off on the side. We're going to write the big one right here because there's our wonderful star. I want to know, how do we find the distance AB?
We should put the line over the AB.
Nope, if we're talking about the length of it, we don't put the line. Okay, so we are going to do all of this really generalized, but just like we did with the midpoints, we're going to see it shakes out pretty easily here. So I would like to work in the first quadrant, but it doesn't really matter. I'm probably going to use first quadrant like 90% of the time. That means positive, positive. Can I place two arbitrary points in here, meaning don't really put any thought to it?
Yes.
Notice there's no scale or anything even. Check it out. Here's point A at x1, y1. And all the way up here we get point B at x2, y2. They might be different locations if we had actual numbers, but they're still just 2 points. Everybody's still cool? Okay. Now, this is a hard distance to count. It's a really hard distance to count. But old Pythagoras hooked it up because maybe we don't have to think about the whole distance. Let's imagine here real quick that I let this horizontal line run straight out, just like we did before, and this straight down. What type of triangle did I form here? It's a right triangle. And if it's a right triangle, what theorem will apply? Nice catch. The Pythagorean theorem. So here's all that I need your guys' help with again. This ordered pair. I don't know. Anybody know it?
X1, Y2.
So x2 is right here. If I drop straight down, have I changed x? So x2 still. And here is y1. Because same thing, if I go straight over, I'm at the same y value. Okay, here's what I want us to see. I have a right triangle, and I'm going to call this C for now, just in our scratch work. And let's dig in. Could you find me the length of this leg? How would you do it? We can, just so you know. How would you find me the distance here? x2 minus x1. Everybody okay with that? If this were 10 and 1, it'd be a distance of 9. 10 minus 1. Okay, x2 minus x1 is that horizontal distance. How about the vertical distance? Thoughts? The difference between the y's? Seems reasonable. So let's go ahead and see if we can't get our formula out. Does this look any different than what we just did? More general points, but it's the exact same thing, right? So help me write the Pythagorean theorem with this one. What's this bottom leg? What did we just say its length was? So if we were writing the Pythagorean theorem, we would have this, and then we do what to it? Square it, plus, what's the other leg? It's that one, yeah? Which we just determined was y2 minus y1. And we do what to it? And that should be equal to c squared. Okay, if I wanted to solve just for c, just this distance, I'm one step away. How do you undo a square? You take the square root of both sides. So I would do that, and I'll do this side, it's c. And then we're just left with a terrible looking expression over here, but I don't want to expand it out. It's just this. Okay. In this situation, I want to highlight something huge that the book does slightly different. I think it's unnecessary. We chose x2 minus x1, I assume, because x2 looks like it's bigger. What if I had done x1 minus x2? Would it have broken everything? Like, I'll even put numbers here on mine. If this were at x equals 1, and this is at x equals 10, if I go the opposite direction, I get a negative 9. What happens inside this formula here, though, with the difference of the x's? I take the difference and I square it. If you square a number, does it matter whether it was negative or positive to begin with? It's always positive in the end. Your book I don't like it because I think it makes it look gross. They put absolute value bars in here, but because we're squaring it, we don't need them. Doesn't matter. We're going to square it. It's going to be gone. Okay, so we all of a sudden, just by doing one Pythagorean theorem, just got our whole distance formula. This is one that I would say on a note card when we get to a test. This is probably something I would have on there, the distance formula. The distance between these two is as easy as taking the square root of x2 minus x1, and we square it, plus y2 minus y1, and we square it. This is just the Pythagorean theorem written in a way that no matter what 2 points I give you, we can use the Pythagorean theorem. That's all that we've done. If you'd rather draw it out every time and actually see the right triangle, more power to you. We're going to do the exact same thing. This is all in the interest of efficiency. Should we do one distance?
Yeah.
Let's knock it out. Okay. Before we move on, what questions do you guys have here? Okay. It's really hard for me to wait for that somebody to chime in. Honor, what's your favorite point on the coordinate plane? Okay, so we're going to say we're finding the distance between x, which is 6, 7, and cool, and z, which is negative, I don't know, 12, 1. I want to find from these, let's find the distance xz. So this is really grammatically weird. I did not think out how I was writing this initially. We're trying to find the length xz. All right. Your pages, Akis, I would wait like 2 minutes if you can. If you're going to pop, go. But, all right, here we go. Helpful, not required. The only hard part where people get goofed up is I'm going to name these points. That's x1 and y1 and x2 and y2. If you're not going to get them goofed up, do you think I really care if you write that?
No.
Not at all. But if you're somebody who puts stuff in the wrong spot when you're doing math, like do this, it'll help you. Okay. Can you guys still all see the distance formula on your page? Yeah. Oh, fantastic. Mine's gone, but here we go. AB equals, it's a big ugly, what's this symbol?
Square.
It's a square root. You will likely hear me just call it root, because if it's a third root or a fourth root, I'll specify. Okay, the square root of, now we're just going to plug and chug. Let's do the difference of the x's. Really, give me one of the x values of a or b. Doesn't matter.
6.
Okay, 6 minus, what am I going to subtract from it, Riley? What's the other x value? 6 minus negative 12. And I'll square it. Anything important I should note here? Minus and negative.
Big add.
Big add. Plus plus. Bless you. Cool. Plus, what else do I need in here?
7 minus 1.
So notice, 7 minus 1. Adeline's staying consistent. But I'm going to square it. Does it really matter if it's consistent?
No.
Nope, I could do 1 minus 7 if I wanted. I'm going to do 7 minus 1 so it stays positive. Squared. Plug and chug will work. All right.
Just gets that equal to C.
AB is what I'm going to call it. Because that's what we're, or XZ, right? XZ, that's my bad. Okay. Prime. What's inside this set of parentheses? And that is what? Okay. 18 squared? I don't know it either, just for the record. Okay, we'll deal with it in a second. Plus, all right, Yash, what does this parentheses get replaced with?
6.
Good? Squared. Okay. I legitimately have no idea what 18 squared is, but I have a calculator in front of me, so that's okay.
Got 324.
Of course, it's 324. Yeah, I like it. So check it out. This is the square root of 324
Plus 36.
plus 36. All right,
Oh, that's nice.
last little step. What's
360.
324 plus 36? 360 is what I hear.
Yeah.
I'm going to add 6 to get to 330 and then 30 more. Root 360. Now, for this class, where we're at right now, I'm good with this. Eventually you'll learn how to make this nicer. You might have already learned that before. I don't know. Anybody ever change this?
Oh, we did something in the inside to get rid of that.
Okay, we'll deal with that later. I'm okay with this answer. This is the distance. Now, if you give me a calculator answer, which I'm fine with, I prefer these because calculators don't make mistakes, or they do make mistakes. If you want an approximate, you could. Anybody know the square root of 360 off the top of your head? Less than 20, I'm sure of it.
12.
18.97 what? If you guys didn't know, I'm pretty sure you typed it in. Cool. Read it again. 18 point. Okay. If you give me a calculator answer, what does this symbol right here mean?
Approximately.
If you give me a calculator answer and you give me equals, am I going to give you full credit? No, I'm a monster. I will not. Don't make your job harder. Stop here. I'm good with it. Cool. All right. You guys are going to get more practice, but I'd rather we just do the more practice on your homework assignment.
So would our answer just be x z is equal to the square root
Yep.
of 360?
Right here.
What's the point for that?
If you give me this one and you say equals this, I'm going to take off a little point. Probably like little, almost nothing. But approximate is different than exact. And we'll really zoom in on that. Zone in on that? Weird. Cool. All right. We have 10 minutes. You guys have some homework. Cool. While you're getting it out, I want you guys to go ahead, open up your books for me real quick because you're going to use them anyway. Let's go to page 24, I think. I'm good with it because I know why I want 24. Okay, check it out. We just finished 1.3. Okay, your book, just as I'm looking at it, I don't think that this book is like ideal if you were going to be self-studying. They don't really do outline stuff. That's just a bunch of examples, and we put it together as a class in here. But what I really want you to look closely at is on page 24, the left side of that. Up at the very top, it says concept summary, right? There are the main points of this lesson, like the main mathy ideas. When it comes time to write note cards and stuff, we will be using those end of section summaries over and over and over because that's what I would put on my note card. It's what you should probably put on your note card. We'll make our first note card together. Cool. All right. So for now, let's go ahead and get to the home. Love it. We're in 5th hour. Okay. Hey, look at that. Midpoints and distance, part 2. Okay. We'll put the link to the video here in just a second. Your homework this evening is homework 1.3, which you will find waiting for you on page 24. You get 9, 10, and then 13 through 25 odd. Okay, reminder on this. As you guys are getting working, should we have to go check any of the odds tomorrow during class?
No.
Why?
Because we should check them ourselves.
All the odds are online on your phone, I imagine, when you're at home checking these. It'll take some practice till I believe that everybody's checking their odds. But the evens we'll always talk about in class for sure. Cool. All right, you guys get 7 minutes now. Sorry to steal the extra 3. And we're going to get some tunes going. I want you guys working for the next few minutes. You're always welcome to grab a calculator back there. I don't care if you use a calculator in class, like totally good with it. Not pointing at you, Ronaldo. I'm pointing past you. Cool. Do it to it. All right. I'll zoom in.